We're moving on to solve problems, word problems, and represent them with equations. You may think of them as real-life situations expressed in sentences. And this is still pretty much a review of Algebra 1. So let's jump right in. Tickets to a Civic Center auditorium for a rock concert were $19. You can tell this was written a long time ago. For seats near the front and $14 for seats in the back. There were 525 more rear seats sold than front seats. The sales for all tickets totaled $31,770. How many of each kind of ticket were sold? I would recommend in this case we might use a chart. And in this chart, when we're selling tickets or selling pens and pencils or whatever it is we're selling, the amount of sales for each item is the price for each item times the number of each item that we sell. So in this case, we've got front row seats, we've got rear seats, and the sales from front and back, the price for each front and back, and how many front and back we sell. So as we read through the problem again, we can see that there were $19 is the price for seats near the front. And we can fill in $14 for seats near the back. Now we're comparing how many more seats. Rear seats, there are 525 more in the back than there were in the front. We don't know how many there were in the front. So what we're going to do is just let X represent how many in front, since we're comparing how many in the back to the front. For the back, it's X plus 525 more, so that's X plus 525. To fill in the next column for sales, the amount of money for sales for front row seats or seats near the front, $19 times X, so that's 19X. And for seats near the back, $14 times how many seats we sold, X plus 525. Now we know that the total amount of money brought in was $31,770. So what we want to try to find out is an equation. It makes sense for this equation that the total sales is equal to how much money we brought in from the seats near the front plus how much money we brought in for seats near the back. And if we now take that and replace them with our symbols, $31,770 is $19 times X plus $14 times X plus 525. And that's the key. The most important part of solving the problem and the toughest is setting up the equation. Once we have the equation, we can just go ahead and solve it. Let's distribute out 14. So we get 14x plus 7,350. And then 19x plus 14x. Let's forget about the chart and the words for a moment. That's 33x. Subtract $7,350 from both sides, so the $31,770 minus $24,420 is equal to 33x. And divide both sides by 33, and we find out that x is 740. Before we go on, we might want to read the word problem again to see if we answered the question. How many of each kind of ticket were sold? We solved for x. So we answered how many were sold in the front of the auditorium, but not how many were sold in the back. So we need to continue with our calculation, and that's 740x, which is x, 740, plus 525 more is the 1265, representing how many seats were in the back that were sold. All right, so there's our first look at one of our word problems. Let's move on to another one. And by the way, any word problem where you're selling stuff, you can use that chart, set it up the same way. This one's a little bit more geometric. We've got Melissa, who's a city planner, has two pieces of wire of equal length. She shaped one piece into a square to represent a new building site, and the other to an isosceles triangle to represent a nearby park. The base of the isosceles triangle is 4 centimeters shorter than the side of the square, and each leg is 9 centimeters longer than the side of the square. How long is the piece of wire? Well, picture's worth 1,000 words, worth a couple of points on a test question also. Let's draw a square, draw an isosceles triangle. Let's try to label some of the sides. We're comparing all the sides of the triangle to the sides of the square. We don't know how large the square is. So let's just call each side S, and I chose S instead of X because S reminds me of square. And we know for a square that all four sides of the square are congruent, so that's why we have S all the way around. Now let's look. The base, that's this one, the short side, of the isosceles triangle is 4 shorter than the side of the square. So from yesterday, we know that translates into S minus 4. Each leg of the triangle is 9 centimeters longer than the side of the square, so that's S plus 9. All right, we've got our diagrams. Let's forget about the words for a moment. Let's remember that the perimeter of a square is found by measuring, adding up all the way around. So peri is around, meter is to measure. So S plus S plus S plus S is 4S. Perimeter of the triangle is S plus 9 plus S plus 9 plus S minus 4. And we know from these word problems right here that it says that the two pieces of wire were equal length. So with that, we can say, therefore, the perimeter of the square is the perimeter of the triangle. Those are equivalent, which means that 4S, perimeter of the square, is equal to S plus 9 plus S plus 9 plus S plus minus 4, the perimeter of the triangle. So now it's just a matter of simplifying. S plus S plus S is 3S. 9 plus 9 is 18, minus 4 is 14. Let's get all the S's together. So I'm going to subtract 3S from both sides. 1S is 14. We've solved the equation, but let's go back and read the problem again to see if we answered the question. How long is the piece of wire? We haven't answered the question at all. All we found is the length of the side of the square. Now you can replace each S with 14 in the triangle, add all those sides together, or since the square, all four sides are the same, we could just say, well, it's 4 times 14 is the perimeter of the square, and that's 56. Since the wire used to represent the triangle was equal to the wire used to make the square, the length of each piece of wire was 56. And I think the units were centimeter. Let's double check. Yep, 56 centimeters. All right, so sometimes instead of a chart, a drawing helps us with organize our information. Looks like we're headed for a distance problem next. So we've got at noon a cargo plane leaves McCare Airport, heads east at 180 miles per hour. Its destination is Jamesville, which is 500 miles away. At 1 p.m., a jet takes off from the same airport, McCare, and flies east after the cargo plane at 450 miles an hour. At what time will the jet catch up and overtake the cargo plane? So distance equals rate times time is the formula we're going to remember from Algebra 1, and a chart is going to be helpful. We need to organize information for the cargo plane and organize information for the jet. So let's start filling in the information for the chart. We know that the cargo plane is traveling at a rate of 180 miles per hour. We also know from reading that the jet is traveling at a rate of 450 miles per hour. So let's fill that in. Now time is not time of day. It's how long you were traveling. So we know the cargo plane leaves at noon. We know that the jet leaves at 1 p.m. So in other words, an hour later. We really don't know how long the cargo plane is going to be flying. That's part of what we need to do to solve this. But since we're comparing the jet's time to the cargo plane's time, we don't know how long the cargo plane is flying. Let's use t for time. Suppose you could use x, but t for time. In that case, the jet leaves an hour later, so its time is 1 hour less of flight. Now let's pause here and fill in the distance column. Distance is equal to rate times time. So for the cargo plane, that's 180 times t. For the jet, that's 450 distributed to t minus 1. We need to find an equation. Well, they're both leaving from the same place, McCare Airport. They're both catching up to each other in space, although not the exact same spot, otherwise they would collide. But what we do know then is that the distance the cargo plane is traveling is the same as the distance the jet plane is traveling. So in that case, we can look at the chart, set up our equation. Distance for cargo plane, 180 t, is equal to distance for jet, 450 distributed to t minus 1. Simplify that. Distribute out 450 times t and 450 times negative 1. Let's have a t party, get all the t's together. Now I subtracted 450t from both sides, which of course gives me negative 270t and negative 450. I did one step in my head, multiplying both sides times negative 1. So 270t is 450, divide by 270, and t is 1 2/3 hours. Now, did we answer the question? Let's go back and look at the words. We found t. It says at what time of day, not how long will it take the jet to overtake the cargo plane. And t represents the cargo plane. So we start at noon, and we're going to add 1 2/3 hours to noon. So 2/3 of an hour is 40 minutes. Noon plus 1 hour and 40 minutes is 1:40 p.m. And that's today's look at our first installment of word problems for the year.